You know, we spend a massive amount of time talking about what you might call the big iron of AI. We get obsessed with, the trillion parameter models, the chatbots that can write Shakespeare, or the image generators that are winning our competitions.
Exactly. But there is this persistent, almost embarrassing blind spot in the technology that, well, nobody really likes to talk about. It's the gap between reading and speaking. And it's a gap that gets huge the second you step outside of, say, English or the major European languages.
That's it. We just assume that because a computer can display text on a screen, it knows what that text means.
Yes.
But then you ask it to read that text out loud to actually perform it, and things just fall apart.
They really do.
And today we are diving deep into a project that is fixing this very problem for a specific slice of the linguistic world. We're looking at a project by a developer named Sydney Awala. It's called Dholuo TTS.
This is a really special one. It's tackling the challenge of text-to-speech, TTS, for the Luo.
Okay, so Dholuo is a Nilotic language, right? Spoken in Kenya and Tanzania.
That's right, by the Luo people. And what makes this project so interesting for a deep dive is that it isn't just another generic voice bot. It's a POS-aware pipeline.
POS aware, and that stands for part of speech aware. And I'll be honest, when I first saw that in the notes, I thought, okay, this sounds like a grammar lesson.
Sure, so it turns out this is actually a brilliant piece of engineering. I mean, it's about teaching a computer that grammar isn't just rules on paper.
It's about the actual sound waves coming out of your mouth. That's the core idea here. In English, you can get away with a lot of, let's say, dumb processing. If I read the word siege, run, in a totally flat voice, you still know what I mean. But in Dholuo and so many other African languages, the pitch, the sort of musicality of the word, it's not optional, it's definitional. It changes the meaning.
So, today we're going to unpack exactly how Sydney Awala built this. We'll look at the specific linguistic trap that trips up standard AI, the grammar-first solution that uses some really heavy-duty NLP models, and then the end-to-end synthesis architecture that brings it all to life.
It really is a masterclass in full-stack AI engineering. I mean, we're talking about everything from custom linguistic rules all the way to cloud GPU training.
Okay, so let's start with the problem itself, because I think most people, they assume TTS is a solved problem. I've got Siri, I've got Alexa, they sound pretty good.
Right?
Why is Dholuo so different? If I just feed a Dholuo sentence into a standard, generic speech engine, what happens?
It hallucinates. And I don't mean it makes up words. I mean it hallucinates the tone.
That tone.
You see, Dholuo is a tonal language. The meaning of a word relies heavily on whether your voice goes up, down, or stays flat. And the source material really highlights this with the concept of homographs.
All right. A homograph is when two words are spelled exactly the same but mean totally different things. English has them. You think of the word lead.
Sure. Like, I will lead the team versus the pipe is made of lead.
Exactly. You figure that out from the context. But in Dholuo, the spelling doesn't change, and often the pronunciation of the vowels barely changes either. The only difference is the pitch.
Okay.
The repo gives the perfect example. The word dhok, D-H-O-K.
Duck, okay. So, to the untrained eye or the untrained AI, that's just 4 letters. What are the possibilities?
Well, depending on the tone you use, dhok can mean mouth.
Mouth, got it.
Or it can mean cows.
Mouth versus cows. That is a significant difference.
It's a huge difference. I mean, imagine you're trying to build a translation app for a farmer or maybe a medical assistant. If you get that tone wrong, you're not just sounding a little weird.
No, you're communicating a completely different reality.
You're talking about livestock when you should be talking about anatomy.
And a standard AI model it guesses.
It guesses blindly. It sees D-H-O-K. It sees no tone markers in the text. So it just picks a flat pitch or some random intonation, and it's usually wrong.
So the whole mission of Dholuo TTS is to stop the guessing. It's to figure out the context before it tries to speak.
Precisely. The system has to disambiguate the meaning first. And the source has another great example that really drives home why this is an engineering problem, not just a translation one. The word ringo.
Ringo like the beetle.
Not quite. In Dholuo, ringo can be a verb meaning to run,
To run.
or it can be a noun meaning meat.
Again, very different things. I assume I don't want to eat the act of running.
You do not. And this is where the linguistic rules come in. The developer notes that in Dholuo, if ringo is being used as a verb to run, it generally needs a high tone marker.
A high tone. Okay.
But if it's a noun, meat, it behaves differently. It usually takes a low tone or a specific pattern depending on the sentence.
So, we have a clear rule then. Grammar equals tone. If the computer knows it's a verb, it knows to raise the pitch. If it knows it's a noun, it drops the pitch.
That's it. That insight is the foundation of the entire pipeline. So, let's get into the how. The developer calls this a POS-aware pipeline. We've got the theory, but how do you actually code something like that? I mean, you can't just write a billion if-then statements for every word.
No, that would be impossible. So, Sydney broke it down into two clear stages, the brain and the voice.
Okay.
The brain's job is just to figure out the grammar. And for the brain, the project is using a model called Afro-XLMR.
Yes, specifically, Davlan/Afro-XLMR-large-76L.
Wow, that is a mouthful of a model name. Let's unpack what that is.
So, XLMR is a huge multilingual language model, originally from Facebook AI. It's designed to understand the relationships between words across dozens of languages.
Okay.
Afro-XLMR is a version of that model that was specifically pre-trained on African languages. So, it's seen millions of sentences in Swahili, Amharic, Yoruba, and Dholuo.
So, it already kind of knows the vibe of the language, so to speak.
It understands the vocabulary. Yes, but just understanding words isn't the same as understanding their strict grammatical roles. So, the developer took this massive model and fine-tuned it,
Sent it to grad school.
basically using a dataset called KenPOS.
KenPOS, let me guess. Kenyan part of speech dataset.
Spot on. It's a dataset where human linguists have gone through and meticulously tagged every single word. This is a noun. This is a verb. This is a preposition.
By training on this, the Afro-XLMR model learned how to look at a new Dholuo sentence and just predict the tags.
So if I feed the system a sentence with the word Ringo, the model looks at it and slaps a little virtual sticky note on it that says VRB.
That's exactly it. It outputs a tag, usually something like V for verb or N for noun.
Okay, so now we have a sentence full of words with these sticky notes on them. We know what the words are doing grammatically, but you still don't have audio. A text file that says Ringo VRB doesn't make a sound.
And this is where we move to step 2, the phonemizer. And this for me is the most elegant part of the whole project. The developer wrote a custom Python script, phonemizer.py, that acts as the bridge.
This is the G2P conversion part, right? Grapheme to phoneme.
Right. G2P is standard in any TTS system. It's just turning written letters, the graphemes, into sound symbols, the phonemes, like knowing that PH sounds like F.
Sure, but this phonemizer has a special superpower: tonal injection.
Tonal injection sounds like a sci-fi medical procedure.
It's actually just really smart logic. The script looks at those sticky notes from the Afro-XLMR model. If it sees the tag verb, the letter V, attached to Ringo,
It doesn't just output the sound symbols for RINGO. It injects a high tone marker, which looks like a little vertical line with a tail at the top.
so it's literally rewriting the pronunciation guide on the fly just based on the grammar.
Exactly. And if the tag is noun or NN, it injects a low tone marker. So the input Ringo V becomes something like, well, that little symbol is a direct instruction to the voice engine. Pitch the sound up.
That is just such a clever way to solve that homograph problem. You're using a deterministic rule, verbs are high, to solve what was basically a guessing game.
It changes everything. It means the computer isn't guessing anymore. It's following a map. And the script handles other complexities too. The source mentions specific logic for digraphs.
Right? I saw that. Things like ni, ng, and dh. These two-letter combos that make one sound.
Standard phonemizers often just butcher those. They'll try to pronounce the N and the Y separately, which sounds completely wrong. This custom script knows to group them correctly. It also handles something called ATR vowel harmony.
ATR vowel harmony. Okay, I feel like I need a linguistics degree for this one.
It stands for Advanced Tongue Root. Basically, in a lot of African languages, the vowels in a word need to share a certain quality, and it's literally about where the root of your tongue is positioned in your mouth.
Wow.
The phonemizer makes sure the vowels agree with each other, so the word just flows naturally.
It's amazing how much hidden work goes into just saying one word correctly. So, okay, we've tagged the grammar, we've injected the tones, we've harmonized the vowels. We have the perfect sheet music.
Now, we need the instrument to actually play it.
The instrument is the synthesis model. And for this, Sydney Owala chose an architecture called VITS.
VITS, which stands for...
Let me get this right. Variational inference with adversarial learning for end-to-end text-to-speech.
Yeah, let's just stick with VITS.
Agreed. But why VITs? I mean, there are tons of voice models out there. Fast speech, Tacotron. Why was this the right tool for the job?
The key phrase there is end-to-end. In the old days, and I mean like 5 years ago, TTS was a two-step process. First, you'd generate a spectrogram, which is like a visual map of the audio frequencies. Then you'd use a second model, a vocoder, to turn that picture into sound. It was slow, and errors could compound between the steps.
And VITS just does it all in one shot.
Basically, yeah. It maps those phonemes, including our special tone markers, directly to the raw audio waveform, and it uses adversarial learning, which is really cool.
Okay.
You have one model, a generator, trying to create fake audio, and another, a discriminator, trying to spot the fake. They basically fight each other during training until the audio is so good, the discriminator can't tell the difference from a real human.
But to train a fighter like that?
You need data. You need a lot of examples of what real Dholuo sounds like.
And this is the grunt work of AI that nobody ever sees. The developer used a dataset called Donam, but raw recordings are not enough. You need the text perfectly aligned with the audio.
So, did they have to sit there and just type out hours and hours of audio?
No, they used another AI for that. They used Wave2Vec BERT 2.0, a massive speech recognition model, to listen to the audio and transcribe it for them.
That is so meta. Using an AI to listen to humans, to write the script, to then train another AI to speak like humans.
It's the standard workflow now. But they were careful. The source mentions they filtered for high confidence. So if the transcription AI wasn't at least 80% sure of what it heard, they threw the clip out.
Garbage in, garbage out. You only want the clean data.
Exactly. And crucially, they also split the data by gender. In the repo, you'll see folders for Wave Male and Wave Female.
Why do that? Why not just one big Dholuo voice model?
Because pitch and tone manifest differently across different vocal ranges. A high tone in a deep male chest voice just looks very different on a spectrogram than a high tone in a female head voice.
If you mash them together, the model gets confused. It produces this kind of muddy robotic average. By splitting them, you get two distinct high-fidelity voices.
Now, running all of this, the Afro XLMR tagging, the VITS adversarial training, that has to require some serious hardware. You're not doing this on a laptop.
Oh, definitely not. The source details the infrastructure. They used RunPod, which is a cloud GPU rental service, and they were running an NVIDIA RTX A5000.
That's a serious card. What? 24 gigs of VRAM?
Around that. Yes, you need all that memory to hold the model weights and the batches of audio data at the same time. It's a good reminder that while the code is open source, the training process still needs some heavy iron.
Speaking of the code, that's one thing that really stood out to me about this repo. So often, research code is just a mess.
Spaghetti code.
Yeah, it only runs on the author's machine.
Yeah.
But this feels polished. Feels like a real product.
It really is. It's designed for usability. First off, there's a live demo. You can go to Hugging Face Spaces right now and just try it.
I love Hugging Face Spaces. It's instant gratification.
And the interface uses Gradio, so it's super clean. You type your text, you pick male or female, hit generate. But for the tech-savvy listeners, the coolest part is the visualization.
Right? It shows you the waveform and the spectrogram,
Exactly, of the audio just created.
which is actually really useful for debugging. Right. You can visually see if the tone markers worked or if there's some background noise.
For sure. And if you're a developer who wants to use this in an app, the repo gives you a production-ready backend. There's a whole API folder that sets up a fast API server.
So I could literally spin this up on a server and build a mobile translation app that calls it.
100%. It even includes Redis for caching.
Caching in a TTS engine. Why?
Well, think about it. If you have an app and 50 people ask it to say, "Welcome to Kenya," you don't want to run the expensive VITS generation 50 times.
Okay,
You generate it once, store that audio file in Redis, and then you can serve it instantly to the next 49 people. It just shows a real production mindset.
it's optimization. It's thinking about scale.
And I also saw a test suite, which is so rare for these kinds of projects. Test Phonemizer with Tagger Python file.
Music to my ears. Unit tests.
And that specific test you mentioned is critical. It verifies that the whole pipeline is actually connected.
How so?
It feeds a known noun into the tagger, and then it asserts, it programmatically checks, that the phonemizer is outputting a low tone marker.
So it proves the logic works before you even try to generate a single sound.
Exactly. It prevents those silent failures where the code runs, but the output is just nonsense. It proves the system is robust. It's really impressive. It's a complete package from the linguistic theory all the way down to the Docker container.
But zooming out a bit, why does this all matter? I mean, aside from being a cool tech demo, what's the real significance of solving TTS for Dholuo?
I think it's about what you could call the linguistic divide. We talked a lot about the digital divide. Who has internet? Who doesn't, right?
But there's a massive gap in AI capabilities between what we call high-resource languages like English or Mandarin and low-resource languages.
Yeah. If you speak English, you have assistants, screen readers, real-time translators. If you speak Dholuo, you usually have nothing.
Or worse, you have tools that misunderstand you. You have tools that turn mouth into cows because they're trying to force English rules onto African languages. This project is a blueprint for how to fix that.
It's a template.
Exactly. It shows you don't need Google's billion-dollar budget. You need to understand the linguistics. You need to respect the language on its own terms. By combining a specialized NLP model like AfroXLMR with a synthesis model like VITS, and then bridging them with that custom phonemizer logic,
Well, Sydney Owala has shown how to preserve meaning, not just translate letters,
it's preserving the culture of the spoken word.
and making sure the technology serves the user, rather than forcing the user to adapt to the tech.
If you're listening to this and you want to see it in action, or if you're a Python developer who wants to dig into the code, you absolutely should. The repo is sydneyowala/Dholuo TTS on GitHub. It's MIT licensed, so you can fork it, play with it, maybe even adapt it for another tonal language.
I'd highly recommend looking at that Phonemizer Python file, even if you're not a coding wizard. Just reading the logic, if noun then low tone, it's a real aha moment. It demystifies the magic.
It really does. It bridges that gap between code and human language.
You know, this whole discussion leaves me with one final, maybe slightly provocative thought.
Oh, what's that?
We've just spent the last 15 minutes talking about how we taught a machine to understand the grammatical tone, the mechanical pitch required by a noun or a verb.
Right? The rules of the road.
But human tone is so much more than grammar. It's emotion, it's intent, it's sarcasm.
Ah, I see where you're going with this.
If we can teach AI to successfully map grammar to pitch, how long until it understands the intent behind the pitch? When does the model learn the difference between a polite thank you and a sarcastic angry thank you just by analyzing the waveform?
That is the next frontier. When the AI doesn't just know what you said, but how you felt when you said it.
And that is both a fascinating and, well, a slightly terrifying proposition.
Indeed. But that is a deep dive for another day. Thanks for listening, everyone.
See you next time.